that is our study part. But then I realized, no, we were studying the Newton. We have studied already Newton's third law. So the next
Yeah.
chapter is gravitational force. You did a lot of numerical based on that, right?
Yes, sir.
So now the chapter is left with you. You do the numericals and send me back. Okay. Where you will
Okay.
start, we will be doing together. Right?
Okay. Yes, sir.
So what could be the definition of gravitational force? You were saying something.
Gravitation is the force that pulls an object to the surface.
Toward the Earth's surface. The screen is visible.
Yes, sir.
Okay, but sometimes your videos are not being so. So what is why this is happening? I'm not getting this. Let me see. Whenever I go to write on the screen, the video went off. Okay, so I don't know why this happens. Maybe some setting from
So your
admin.
camera is going off because it's not going off.
Sorry.
The video is not going off, sir.
Participant, can you see? See, gravitation is a feature of massive objects. Massive objects. Massive. MAWSIV, massive objects. Okay. We are on the Earth. Earth is a massive object.
Yes,
It's
sir.
round in shape. We are on the Earth. So Earth is pulling us with a force. We can't leave the Earth's surface. Whenever we walk, because of our center of mass, this is our body. So this always pull ourselves toward the Earth's surface. Okay, and that force is always, the gravitational force is always toward the radius of Earth. The
Okay, sir.
gravitational force is radial in direction. Radial means if you are standing over here, this is the radius of Earth, it will pull you on this side. You are doing something?
No, sir, I'm taking my notebook.
Take it, okay. So it's always toward the radius. So when a force is toward the radius, we call it centripetal force.
Okay, sir.
Whenever any force is toward the center, we say this is centripetal force. Can we go a little bit advanced?
Okay, sir.
Because you have already studied this chapter in your classroom, right?
No, the gravitation we haven't started yet in school.
So school is open now?
No, school will open on September.
Okay. So see, what we mean by, whenever we talk about the force, there will be one thing associated with it, that is acceleration. Whenever there is acceleration, there is force. So there will be an acceleration. ACCELATION. So acceleration is a vector quantity, we all know.
Yes, sir.
So acceleration will be v square over r. This is, sorry, we have written the radius r of this Earth, and this will be always, if suppose we are taking a revolution around the Earth. This is Earth.
Okay.
Okay, we may take this as well, but this is a small height. Suppose this is a small. This h is very, very less than r. Okay, so suppose we are at the Earth's surface. You may think that you are tying a stone at the thread and you are welding it. You do like this?
Yes, sir.
Okay.
I've tried a lot.
So this is our center, and the stone along with thread is rotating around the center. So if we see this earth is our center and this object is revolving around it. Okay. So what happens if thread get broken?
It will fall down.
It will fall down. You mean say that, see, I'm just changing the pen nib color. Changing the nib color. This is me or you. This is a thread. Okay, this is a big stone, and we are revolving it around. Okay,
Okay.
this is me or you, whatever it is. We are revolving this stone. Okay, this is its velocity. This is a tangential velocity, and this is its radius. So what happen if this thread will get broken? So a stone will come inside or outside?
Mm.
A stone
It will
will
go
come
out.
inside or outside. This is a stone, okay? A small
It
stone
will,
thing. It will come inside or
it,
outside.
it will come outside.
Sure? It won't.
I'm not so sure. If you're doing it very fast and then you let go, thread
No.
goes out, it'll
Yes.
come faster
We are
outside.
doing with intention that thread should broke. Thread should break. With that intention we are doing. We wanna
Then
see. We wanna
it'll
see
go
that
outside.
it will go outside. Okay. It will go outside. It will never come toward the center. Okay.
Okay.
Because they see this is the centripetal force. Centripetal force is inside, and to balance this force, there will be a centrifugal force. Centrifugal. This centrifugal force is pseudo force because we know that for every action there is reaction.
Yes, sir.
For every force there is one opposite force. So if you see that always there will be a tension in the string. Okay. You will always find tension in this string. So that tension is being balanced by this centrifugal force.
Okay.
So actually this you will read in class 11th or 12th, class 11th and 12th, not now. Okay, just to
Okay.
keep in mind, this comes in the picture. Okay, so what happen if some object is here, there is no environment. Okay, in this case there is no environment, no gravitational pull or push. So here there will be one acceleration v square over r. This will be
Okay.
centripetal acceleration in this case as well, and whenever we move around this. For example, this is stone, or you may think this is moon. Okay, you may think this is moon. So moon is always revolving around the earth or other planets due to a centripetal force. So this is centripetal acceleration. If we wish to find the centripetal force, so there the earth mass will not play any role. Okay, so this will be mass of the moon or any object and v square over r. This is the advanced concept. I warn you. Okay, so this,
Okay.
okay, so this is because the textbook only says that the moon revolves around the earth due to centripetal force. How it
Okay.
comes is not being discussed. Got the point?
Yes,
So
sir.
what happens? This force try always to keep the object toward the center. toward the center. So it doesn't fall back or go away from this. So whenever Earth apply a force on any object, this is always in radial direction.
Okay.
Or whenever Earth pull any object, in the case of free fall, this acceleration will be acceleration due to gravity. This acceleration will be acceleration due to gravity. Due to gravity. Got the point?
Yes, sir.
If we see that, is Newton's third law valid in this case? Do you
Yes,
think
sir.
Newton's third law valid in this case? If you think so, it's good. Okay. Now, suppose we won't go in much detail. Suppose Earth and Moon system. For this Earth and Moon system, how the gravitational force takes the form. What is the form of gravitational force? What is the this red colors looks you better or black one?
Both are okay, sir.
Both are okay. What about the tip size? Fund is
That's fine.
okay.
It's fine, sir. It's
Fine.
fine.
What is the
Yes.
form of gravitational force? Gravitational force. Okay. How this gravitational force can be written in mathematics? This is our point. So we have two object, mass of two object. One is what? One is Earth
And Moon.
and Moon. We may say that Earth and Moon system. So mass of Earth will be mass of E and mass of Moon will be m of m. Clear?
Okay, sir.
Or should I write EARTH? Or
It's understandable, sir. It's
okay,
understandable.
so it's good. So I'm again writing it equals to mass of Earth, mass of Moon. Sorry, mass of M. So there will be a distance between these two. If
Yeah.
now we see that this is Earth and this is Moon, and the separation between these two is minus R. Okay. So how this gravitational force comes into the picture? This is mass of m of E and this is m of m, right?
Yeah.
So this will be proportional to product of two masses, m of E, m of m, right?
Yes, sir.
And inversely proportional to the distance square between these two. Clear? So
The
if
inversely proportional, what do they like? Half of
1 over
I
r
don't
square.
know.
Inversely proportional means, just a minute. Inversely proportional, INVERSALY, inversely proportional. What does it mean? See, we write, if we have a number f, if we have a number x, so what will be 1 over x?
Yeah.
Is the inverse?
Yes, sir.
Inverse of the number. So here,
Yeah, so it'll be.
got the point?
Yeah, sir. Yes, I understood.
Okay, so it will be inversely proportional to the distance between two planets. So
Okay.
so if we will write that, then G, the gravitational, sorry, I'm writing this G. It will come in this is FG, gravitational force.
Okay.
This G should come in a small font. So let me correct it. either we may write it Fg, or we just omit it, no problem. But for the simplicity, just to make it clear, we will write this a small g. Okay, and later we will remove it.
Okay,
Gravitational
sir.
force. Now this is a product of mass of Earth into mass of Moon divided by this separation r square. Okay. So
Yes, sir.
now we have to change this constant of proportionality to equal sign. So how we will do? V F G will be we will take a constant called G. This is gravitational constant, m of
Okay.
G into m of mu divided by r square. Got the point?
Sir, we're finding the force of gravity. So how will multiplying gravity with the mass by radial?
Yes. We have the constant for this. This is 6.67 in 10 to the power minus 11 Newton meter square or per kilogram. We will see. I'll go
Yeah.
back to the chapter, okay, and we'll come back with some numericals so we can understand it, okay.
Okay, sir.
So now in nutshell, what we will do, we will omit all the subscripts. So we will write it like F. This will be G. Mass of moon will be capital M. Mass of earth will be a small m. And the separation will be R. You may write capital R square as well.
Okay.
That's already we know. We have to say that what is each and everything. Okay.
Yeah.
So reader or examiner, for the simplicity of, we understand what is all these quantity, but examiner doesn't know. So we have to write that where G is gravitational constant. Gravitational gravitational constant. It has some
Okay.
value. Okay, what's the numerical value? It's 6.67, but I'm not sure about the dimensionality. How we find the dimensionality, I will tell you soon. Capital M is mass of Earth. If for the Earth mass system, okay, Earth Moon system, mass of Earth. Similarly, we will write a small mass is. If you will follow these practice, your concept will be clear, and as well as the reader will be happy. You will get more marks.
Okay, sir.
M is the mass of, it means that you understand everything. Mass of moon. Okay. And R is the distance between distance BETW between Earth and moon, right?
Moon. Yes, sir.
Now, if we want to check the dimensionality of any given quantity anywhere in the problem, what we have to do? See, this is F, and we may write it with Newton, right?
Yeah.
This is a symbol of Newton. This mass,
Yes, sir.
M, is in kilogram, right? Similarly to a
Yeah.
small as well. And this R is meter.
Yeah.
Meter. I'm writing it because I already written a small mass over here. So meter, and then I will write a small m. No problem.
Okay.
So now
Yes, sir.
this force will be Newton, and this constant will be as it. M into m will be kg square, and this R will be divided as meter square, right?
Yes.
Now this G is unknown, so just do simple mathematics. Just take Newton is at is, don't disturb Newton. let him RIP, and this kilogram square, this turns out to be the value of constant. This is the dimensionality of constant.
Okay, sir.
So if you are not knowing the dimensionality of any constant and then formula is given to you, just do these simple mathematics and you will get the results. Clear?
Okay, sir. Yes.
Okay, so write it down. I'm just reducing the size and I'm going back to my phone work. I'm checking the screen is visible.
Yes, sir. Yes. So could you scroll?
Is what happened?
Could you scroll? Scroll
Okay. Down or up?
up, sir. Sorry, down, sir, down.
Till this, I think, no?
Yes, sir, this one I was right.
Okay.
So finished.
Okay, so now to understand this, we have a small numerical. Is readable.
Yes, sir.
Okay, so can you proceed?
The mass of the Earth is 6 into 10 20 to the power 24 kg, and that of the moon is 7.4 into 10 to the power of 22 kg. If the distance between the Earth and the moon is 3.84 into 10 to the power of 5 kilometer, calculate the force exerted by the Earth on the moon. Take G is equal to 6.7 into 10 to the power of 11 Newton meter. So should I tell you what to do, or should I write it on my own.
First, tell me how to do, what to do, and then solve it on your notebook, and then show me.
We will first we'll use the equation of for Newton is equal to gravity into m by radial, which is gravity into kg square by meter square.
So F will be G time M1 into M2. Okay, now,
Square.
so, and there's the separation between this R square. Okay, so what's we have to do? We have
Gravity.
do solve it. We have given all the numbers now.
Yes, do we multiply it like 6 into 10 into 7.4 into 10 like that?
Yes. First of all, see, what is the dimensionality over here? Newton, force is in Newton, mass in kilogram, and distance is in meter. So here distance is in kilogram. Sorry, kilometer. So we have to convert it into meter.
Yes.
First do that. Whenever you do the numericals, you check the dimensionality. See, in this constant as well. One second. 1 second. See, it's given the take G this value now. It means that there is the cross mark. The force, this all quantity will be in this in standard. Okay, Newton, meter, and kilogram. So you already given, you got the hint. So you have to keep the calculation in these 3 units.
Okay.
So see, this is already given in kilogram. This 2 is already given in kilogram. And this is in kilometer. So it hints that you change that first.
Okay. So it will be 10,000 meters.
Yes. 1,000 meter, 1,000 meter. 1 kilometer is equal to 1,000, 10 to the power 3 meter. That is 1,000 meter.
Okay. I'm confused how to proceed, like how to multiply and all.
Where there is confusion, there is challenge. Okay, that's the challenge. And that challenge will make you stronger. That will
Mm,
increase your mathematical ability as well. So if I'll solve, your those ability will not come up. I can do that in
Okay,
one minute, but I want to see from you.
okay, sir. I think I got the answer.
You got the answer, but I don't know the answer. I only know the procedure. If you will say that answer is this much, I'm blank. I only trust if I'll see the procedure. So now I'm doing okay.
Okay.
You tell me. First of all, tell me what is the R.
R
See,
is 3.8.
3.884 into 10 raised to the power 5. This is in kilometers, so I will write it again. 3.84 into 10 raised to the power 5 into this meter,
1000, which is 3.84 into 10 to the power of 8.
10 to the power 8. This is meter, right?
Yes, sir.
So that's good. Now
Mm.
the another thing is, tell me what is the masses of these two objects? 6 into 6 in 6 m1 into
First,
m.
6 into 10 to the power of 24.
6, 6 into 10 to the power 24. Both are in kg and 7.4 into 10 to the power 22.
22 kg.
Okay, so this one, did you get this
Mm.
one?
So I didn't do it
No,
like
no, no, no,
that.
no.
I did like multiplying with the gravity and like the equation I went through. I didn't go like
Okay, no problem.
separately.
No problem, no problem. So it's true?
Yeah, it will be true. Yeah.
Okay. So the next step is, okay, as you did, we will do like that. So this F will be, what about 6.67? 6.7.
Yeah.
10 raised to
7
the power minus 11.
into
Their mass will be 6 into 10 raised to the 24 into 7.4 into 10 raised to the power 22 divided by 3.84 into 10 raised to the power 8. This is square, right?
yeah. So
So this is the
equation. So then I cut the 10 to the power
okay,
of 20, 10 to the power of 24.
that's good.
And
I know you have approached in a similar or certain manner. So what I will do, just give me 1 second. 6.7, I will write that this. No problem.
yeah, no problem.
Okay. Then
10 to
6
the
will be
power
as it
15.
uh 10 to the
6.
24. 24. Then 74 over 10. 10 raised to the power 22. What will be the, this one is interesting. This will be 3.84. We are removing
Mm.
this 100. Again, 3.384 by this. This is square, so we will be writing it. And this will be 10 to the power 16. You approach in the same way?
16.
Yeah.
Say, are we multiplying 8 or we're adding 8? Okay.
10 to the power 8. And this is the square, right?
Yeah,
So
so
what
I
does it
thought
mean?
we'll.
What does it mean? 10 to the power 8 into 10 to the power 8. So if
So 16 will be 16. 10 to the power 16.
now your answer is wrong,
No, sir, I didn't go like by 10 and all. I went cutting and then
so
I multiplied.
how did you solve this? That's this. How did you
I
did this?
I cut out first 10, 20 to the power 24, 10 to the power
You
of
forget.
20
So,
to stable, and
so
I
did you
don't
retain it? Did you retain it like 10 to the power 8 into 10 to the power 8? Did you
know. I
retain like
forgot.
so? How
I
you
forgot.
how yeah? So that's the wrong thing. Now, I was knowing the key point where you might make mistake. So we have to write this quantity twice. Okay, and
Okay.
then you have to proceed. You got the
Mm.
mistake? That was your mistake,
Yeah,
right?
I already knew my answer was a mistake after doing all the calculation.
Hmm. So that's called the experience. Okay, you don't have to worry
Mm.
about that. So this
Okay.
comes 10 to the 86. See, this is now if we will again move, I know that experience will make you good at mathematics. Okay, so
Okay.
do the calculations as much as you can. So this is 67, 6 and 74, and I am writing this 10 to the power minus 11, 10 to the power 24. This is 24 or 26?
It is 24.
Yeah, I know that.
24.
24. Okay. Plus 22. And
Plus
this will be
22.
10 to the power minus 2. So it will be again minus 2. Okay. So
Yeah.
it's 10 to the power 10, 10. This is 100. So 100 means 10 to the power minus 2, right? And this
Yes.
will come. Okay. I won't make you more confused. And this will be 384. 384. And here it will be 10 raised to the power 16 minus 4, right? 10,
Yes.
100 and 2, 2. So this is your number. This is your number.
Yes.
If you wanna cancel it, cancel it. If you wanna go with full calculation, go it. Now you may take this up a stair. Here, you adjust it. Okay.
Okay.
So this will be, and now you solve. This is a force, and we all know that force has what unit. You may write the dimension at the end and cancel the kg to kg, meter to meter, second to second. No problem. Okay.
Okay, sir.
And it's already 10 minutes left in our calculation. So you do it after the session.
Okay, sir.
My hunch was that you might made a mistake over there. So that's why I did it myself. Okay.
So
So
it's a
now,
big equation, big number. I fully got confused. That's why.
no problem. People do this now. That's why this world is working. Okay. So now
Hmm.
this was our moon. Sorry, this was our Earth with capital mass M, and this was our moon with a small mass m.
Hmm.
So this Earth is pulling it with a force F, that is equal to G capital M. Capital M is the mass of Earth, a small
Hmm.
m, and the separation. This is this is R square, right?
Yes, sir.
And Earth, this 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 may be equal to mass time acceleration.
Yes,
This is
sir.
the gravitational acceleration. So what we will get from this equation, we may cancel this m to m, and we will get G is equal to capital G mass of m divided by r. So this, if you will put gravitational constant, mass of Earth, and the separation between Earth and Moon, you will get it 9.8 meter per second square. G is the gravitational constant, m is the mass of Earth, and r is the distance between Earth and Moon. You do this calculation
Okay,
and you will land up with this. Okay,
okay, sir.
so write
Okay.
it down and good night for the day. It seems
Okay,
you are
sir.
tired.
No, because I had one more tuition in the morning. That's why.
Okay, then write it down and then we'll meet day after tomorrow for math class. Okay. Read the
Okay,
new
sir.
chapter.
Mm.